are live. Hi, everybody, and welcome back to Dev Show. My name is Sherry Liz, and I am your host today, not with Rasmus, but with another colleague of mine, Irina. Hi, Irina. How are you doing today?
Hi, Sherry. I'm great. Thank you. And how are you?
I'm fine, thanks. I see that you're sitting outside enjoying the weather.
Yes, well, you need to catch your chance. It's Denmark. It can change any other minute.
That is true. What happened to Rasmus?
Well, we could say that he got a new haircut, a little bit of blonde.
So today I can literally say that we have Rasmus version 2.0. So to you, Rasmus, if you don't join the session, that will happen. So, but thank you very much for hosting me, co-hosting the session with me today.
It's my pleasure.
Yeah, I'm going to come back to after I say a little bit about the logistics. Then you can explain about the session for today. So for those of you that is the very first time that you're joining the Dev Show, it's a weekly event every Tuesday, same time. And on each session, we normally have one speaker and one topic. And at the end of the session, we have a Q&A where we really want you all to ask a question from the speaker. And the way that you can ask the question, no matter from where you are watching us, from Learn TV, from Facebook, from YouTube, from anywhere, you can just type your question in the chat and ask. I will highlight it at the end for the speaker, and he's going to answer that question. Speaking of typing, we really want you to engage with each other. Even let us know that from where you're watching us, what are the topics that you want to see in future. Let us know or chat with each other. But once you're chatting, I really want you to familiarize yourself with a code of conduct, which I highlighted here. So really, I want you to familiarize yourself with the code of conduct, but in short, we just want you to be mindful and respectful of each other. When it's needed, we are going to enforce the code of conduct. It never happened, and I really hope that is not going to happen at any time. And speaking of, again, questions, our speaker is going to choose one of the questions at the end who is getting the swag box. You can say that it's a question that either started more discussion or the best question, more relevant question, but the speaker, we offload that task to our speaker to answer to choose the question. And then I'm also going to highlight a link to get your Azure Heroes Learner badge as usual, and also the link to our feedback form to tell us that what you want us to improve, or if you have the feedback for the speaker as well, please fill out that one once I highlight the link. And also one of you who fill out the feedback form also going to get a swag box. What a way to get the swag box. Back to you, Irina. So what do we have on the agenda for today?
Well, with so many swag boxes and prizes, it really feels like Christmas. But today we will learn about Kafka and Kafka Event Hub, about basically streaming data to a data warehouse and then how it is materialized in the Power BI. So Apache Kafka makes real-time data available to other applications, and there are numerous use cases for it, such as livestock trading or fraud detection, data integration, real-time analytics. So I think it's time for introducing our speaker today. And fun fact, he actually moved from sunny South Africa to enjoy the Danish weather. Hi, Morne, how are you?
Hey, Irina. I am very good. Hey, Sherry.
Hi.
I'm enjoying kind of the weather. It's overcast, not too sunny, enjoyable.
Yeah, I guess I have one more fun fact is that you're from South Africa, and as our kind of that the speaker for last week, he was from the South Africa, and the next week also going to be from South Africa. So you can say that we dedicated the June to South Africa. So.
Yeah, you should have had a South African flag somewhere in the advertisement for the sessions, at least.
Yes, that's true. So we definitely know that there is one thing we don't have in common. That I really don't like this weather, the Danish weather, but you like it. So.
I'm sure there's more than one thing, right?
but we have one thing in common. Look at the bright side. We both work at Microsoft.
Yes.
So you are working as cloud solution architect. Maybe you can tell us a little bit more about that. What do you do actually as a cloud solution architect at Microsoft?
That's an interesting question, right? It changes from day to day. Most of the time, I don't do much. I listen to people, right? I listen to the plans they have, how they want to implement technology, and then I give them advice as to how to do that, best practices and so forth. So interesting work. It's different every day. I really enjoy it.
Great. Good to know. Irina, do you have any more questions to Morne, or we start the session, because I can see people are waiting and it's 8 minutes past.
Well, I was told not to ask Morne about the hobbies, but
oh, come on.
It's really tempting now, only because he asked me not to.
Yeah.
Okay, what's the typical hobby in South Africa?
Typical hobby. Oh, wow, that's interesting. There's a bunch, right? It's a big country. It's a hot country. There's a lot to do. Going out and looking at nature, right? That's a really big hobby. People go weekends on walking tours in South Africa. Where I used to live, there was, so for me, it's always funny when I'm in Europe and people are like, oh my goodness, I went to this game farm and I did this hole and I saw animals and, and where I used to live in the middle of the city, that was not even an hour's drive. I could get there. That's a little boring. We can maybe take the kids if I can't think of anything better to do. I would say in South Africa, it's getting out in nature and barbecuing. So pro tip, if ever you want a good barbecue, invite a South African to barbecue for you. We like being competitive in barbecuing.
Do you have plans for the Friday? Maybe some barbecue?
It sounds like I do have now.
Fantastic. Done. Okay. I think now it's time to actually start.
All right.
So I'm going to share your screen when you're ready. And we remove ourselves from the screen. And to all of you who are listening to us, please make sure to type your question in the chat box. We are going to highlight it later on for Morne. So, yeah, I can see your screen is... Yes.
Right. So let's speak about event hubs and Kafka. What you're going to note, and typically if I'm presenting, there's one thing you can kind of guess. We're going to be talking about data at some point. We're going to be talking about databases, because that's normally what I do. I do write some code, and I'll show you a couple of things in code as well. But we're going to talk about how easy it is to use Kafka streaming using Event Hubs itself, and then how we progress this data to get it into a data warehouse, and then eventually display it in a report. Because I mean, this is the point of it, right? When you look at any kind of information, any system, it's only as useful as the end event that we get, right? So in a lot of cases, this would be the report itself, right? So someone would be looking at this report and it would be surfaced off of a data warehouse or a cube or something like that. But we need to get the data there, right? And Kafka and Event Hubs gives us a really awesome way of doing it, but I don't want to run too much forward. So let me start talking, right? So what is big? Let's talk about big, right? We do about 1.8 trillion requests per day in Event Hubs. About 269 billion emails, 1.4 billion active daily users on Facebook, 3.9 billion internet users. These numbers are huge. So when you start looking at this, and when you design a system, and when you think about a system, right, and I need to get this information in, we start thinking about streaming. So can I stream this information in? Because imagine these numbers, right? how easy would this be if I wanted to get this data in? And then you move into the real world. And the real world, unfortunately, doesn't drive like this when we look at data. Right? When we look at this big data, we're going to get it somewhere, and it's normally not streamed. We're going to get it in files. And what's happened is we've decided to batch all of this data. So we're doing batch processing. This is stock standard. Everyone does batch processing. And when I say everyone, there's always this little asterisk at the end of it, unless you don't really do batch processing, and then you're excluded. But for the majority of companies, there's always batch processing. The problem with batch processing is essentially finding a point in time where I can process this amount of data. And you've got to be kind of smart about it, right? So you've got to say, well, I get a bunch of data, and at 7 hours of getting data in, I need to process this, because otherwise it gets too big, it takes too long, and my system is down, or my data is really stale. Which then means you need to find a really cool spot after that 7 hours to suddenly start processing this data to get it into your system. You might say, hey, I need data in every hour, right? So imagine yourself that's sitting in front of a system or looking at a company and saying, how quickly do you want to get data in? So how important is it to you? So if you're looking at a salesperson, if you're looking at a manufacturing plant, they want data almost real time, right? Other systems, it's okay if it takes a couple of hours to get this information in, right? So no real problem. And this is why we do batch processing, right? We get them in batches. We have this ETL process, and it kicks off normally at a schedule, like I just explained, right? And there's decades and decades worth of history and tools dedicated to these batching. And you'll see when you talk to people, this is normally what we talk about. So when we talk data and ETL, getting it into a warehouse, we're going to talk batch, right? And man, batch sucks, right? Now you'll see it can have some benefits, but the real thing is it's a compromise, right? It's a compromise because systems simply aren't fast enough, right? So we can't do this real time. We can't get the data to the place that we wanted in real time. I spoke to a customer the other day where they had a requirement from where the record was written down onto storage in another database in another cloud provider into Azure. They had 10 seconds from this event happening to where it should be available in a Power BI report. Now, this is an interesting aspect because you're looking at some of it and you're saying, well, how long would it take me to get the information from this event being written into Azure alone, right? So that's about 3 seconds that we looked at, right? So the high end is 3 seconds. So we could make it work. That leaves us 7 seconds on the other side to get this data in. Biggest problem here, though, is there was a batch process. So the batch process actually moved it through 3 different layers to make it available to the reports. Now, we could land it 3 seconds onto the database. So it gets into the database 3 seconds. But moving it through these layers that was, I think, 4 minutes, right? So completely and utterly missing the 10-second part. And this was due to the batch. So there was a batch process that had to kick off every X amount of minutes, and it would just flood the whole system. Now, how do you do real time? You turn around and you say, well, maybe we need to relook at batch. Maybe we need to look at streaming capabilities, right? So fetching it from different sources and then bringing it into the database near real time, right? So within that 10-second window. And this is where Kafka steps in. This is where Event Hub steps in, right? We fetch it and we stream it into the data warehouse where we want it and need it. And then we just process as we go along. So we don't have to have this batch aspect to it all, right? You'll see there, that's the issue of it all, the slowness of it all, right? How long can I wait for my data is important. and then cumbersome because we will have this ETL job, right, that we need to look at, and we need to build that, and we need to plan it. So essentially how most ETL work, ETL is export, transform, and load. So you're going to export it from one system, you're going to make some changes to it, and then you load it into a data warehouse. Now, these days, we tend to talk about ELT. So export, load, and then transform it in your data warehouse, because we can do it fairly fast here with all of the resources we have. And this is a better approach than pure batch ETL. So we stream it in, we use the power of our data warehouse to do direct transformation, or otherwise we just surface the query that they want. So we do the transformation as they request the information, right? So we can then say in the background, we can still do our batch, but we can also surface the real-time information directly onto a report. I like that approach, to be honest with you, right? And batches everywhere. You'll see it. If you speak to a company, guaranteed they're going to do some, they're going to at least do some batching, but I'll bet you that 9 out of 10 companies will be doing, majority of their processing will be pure batch-based. Right. And this is a joke that I completely forgot about, right? In my last paycheck, my death certificate will be batch processed. And I was thinking, so if we look at the next slide, if we look at real time, what does real time give us, right? So it allows us to process our data individually rather than in sets. So I don't have to get this huge set and then work with it. I can just do it as it comes along, right? Piecemeal. It's much easier to model, right? We can do the business logic, we can do the transformation right there, and it's more the way that we think. So we don't have to go through this whole ETL process where we've got to define business rules in another tool and then do stuff, transform and then load it. We can actually just transform right there, right? It makes it bunches easier, right? And it's much faster in terms of performance. And the thing is, I mean, just simply think about it. So imagine I'm exporting data, and that means I'm writing it somewhere, right? So I'm placing it elsewhere. And I imagine it's a really busy company. So imagine a financial institution, something that carries credit card information, right? So every time that card is swiped, they might want to put it into their data warehouse. So what they do is they export their database every X amount of hours, and then you need to re-import it. Now, just imagine having to import, let's be nice and say 500 gigs on every batch job. So 500 gigs on every batch job means that there's an amount of time of just copying data, right? Because it's fairly large. Now, the benefit here in real time is as that transaction is happening, it hits our data warehouse. So it's a singleton insert essentially, right? So we could do some batching to make it a little bit more smart. But essentially, it's singleton insert against our database. So we're getting it as hot as we possibly can. It's about a 3-4 second delay from process to hitting the data warehouse, which means we can respond to this really easily. So if we're looking at a financial institution, we can look at fraud, and we can catch it rather quite easily and quite quickly by being able to do these kind of things, right? We can also spot trends really easily. So imagine someone like Twitter, or Facebook, if I was on there and I was running a competition, or Sherry and Rasmus running the show, being able to see real time the responses. So imagine there's thousands and thousands of people here and they're posting on Twitter going, hey, I really don't like this guy's tan because he doesn't get in the sun enough. And then they can, see the sentiment from all of the comments real time and then kind of respond to it, right? So if people are saying, maybe it's moving too fast, we can slow it down and so forth. So you can respond to these things immediately, right? Which has huge benefits to a lot of places in where we are, right? So imagine your car. And I mean, now if you think about some of the things, it has to be batch probably, right? So imagine, like I said in the previous slide, my salary is batch-based. Can you imagine if that was real time, right? You get paid by the minute or the second, right? So your bank account just keeps on climbing. It's ludicrous if you think about it. And the only reason why it's ludicrous is because that's how it's always been. Now, if you know me, you would know that I'm not one of those people that go, this will work because this is how it's always been. It's got to be this way, right? We always try and find something better. We try and optimize it. And this is where Event Hubs and Kafka steps in, right? this, let's do it in real time. Let's make this run. We won't have just slides. I've got a demo as well. I've got some code. So I've got some Kafka code that's executing against an event hub, and it's streaming some information in. And I'll take you through this process with the event hub, how I get it into the data warehouse, and kind of what that means to you. And then I'll show you the Power BI part of it as well. But let's get through some slides, right? The exceptions and so forth, right? But let's talk about why is it important for to be faster, right? It's the time value of data. So sometimes this information is super important to have, right? So I don't want to see just historical. I want to see real time immediately. So imagine your manufacturing plant. You have got these machines. They're doing whatever they need to do. So let's imagine we're Lego. We're building these blocks. I want to know how many blocks are being built per second, per minute, per hour, right? Because I want to see what this curvage is I'm going to make my target for the hour, I'm going to make it for the day, and so forth. So if something has gone wrong, so if the machine is going wrong, so imagine this machine is stamping and it's actually slowing down, right? I can spot it immediately. So if I don't have a machine learning model on top of this, I can just spot this happening. So suddenly I have 6 machines as an example, and they're running next to each other, and I can keep an eye on this in real time. I can spot this happening. So I can spot that a machine is not doing what it should be doing, right? But I'm sure most of you see the value in this, right? What we do with real time, and why real time is important, and why it's important not to get the stuff late, right? So immediate value. Some of this just loses value over time if you think about it, right? So if I know in 2 days what the machine was doing today, would I be able to respond to it, right? Or let's say my car is saying, hey, your tires are flat, right? Or there's an issue on the engine, but I only find out about it 2 days later because it went through some batch. That's not really useful to me. So that data lost tons of value. And we want to capture that value on the data. And this is why Kafka and streaming becomes super important, right? But let's talk about a typical data pipeline. You'll see we have producers, we've got collecting or staging, we've got ingress and capture, processing, storage, and then presentation itself. So at the one end, we have, let's say, Power BI. At the other end, we have whatever we have. Something is generating events for us, right? So it's generating this data. And we've got to catch it and stage it, and then we've got to ingest it, process it, and then store it, right? So now you can see all of the steps, right? Let's talk about a little bit more about what Kafka can do for us. You'll see here, this is the traditional staging strategies. So for files, it's easy to work with. You can multi-read, replay. It contains natural order. We've got queues. And this scales out much better than files. It can be transactionally consistent, but you can't replay it, right? So queues are useful, but Kafka, not being queuing system, makes these messaging a lot easier for us to do. Databases, it hurts my heart when I see that heavyweight. So databases are super heavyweight, right? You need some serious resources behind it. It must be transactionally consistent, which means I've got to go through a bunch of steps, and we call it ACID, to make sure that every transaction, so every write or update that we do to a database must be consistent. So I should get the same answer at all of the times, right? And I'm not talking about the other stuff where you can have ghost reads and so forth. I'm talking when the data is committed, it must be completely consistent. But there's a cost to that, right? So it's expensive to do this, and that's why it's heavyweight. And you can replay your event, so you can execute the same query over and over and over, and you're going to get the same result based on the same set of criteria, right? And then obviously more databases to manage. Now, what makes this important, that last point there, more databases to manage, it's the same point of view for me with spinning up your own Kafka, so having these VMs around and managing all of that, right? And this is why we're going to talk about event hubs. So event hubs gives you the benefit of Kafka without having to be in control of it. It's like the other day, someone was asking me how you do something on a Windows server, and I couldn't remember because I haven't worked on a Windows server in quite a while. I typically work on the Azure services, so SQL databases, Synapse, and so forth. So I haven't seen a server operating system in quite a long time. And for me, it was shocking. And this is where I was taking a step back, and I was thinking, that's actually quite nice. Right, and this is what you need to ask yourself as well and say, I mean, let's be honest, there are going to be people who want to set up a virtual machine, they want to install Kafka, Zookeeper, and do all of the rest of the stuff, and that's fine. If you're okay with it, hey, we're all okay with it, right? But occasionally, you want the service, and you don't want to have to worry about it. You don't want to worry about, how do I do DR, right? Do I have enough disk space if I want to persistently capture what's being sent to me? So all of these messages, if I want to capture them, how do I manage this disk space, right? And how do I archive? And so all of these are things you would need to take care of if you roll your own, right? So in Event Hub, what we can do is we essentially spin up an Event Hub, and it's 3 steps essentially that you use, right? And Event Hub then feeds other things. So the one perfect thing for me about Event Hubs is it's one central place where we can connect multiple sources and communicate from multiple sources to the same place. So I don't have to think that, hey, I've got a .NET app and it was written by someone 6 years ago. That person's left the company. We don't really know where the source code is. And it's a C# app. It knows only how to communicate over HTTPS, as an example. I can change where it communicates, but I need it to communicate in this way. And this is where Event Hubs makes it really, really kind of useful. So instead of me having to target a Kafka protocol, I don't have to. I can switch to Event Hubs. So I can have a Kafka Event Hub talking to C#, right, without having to have any Kafka components in my C#, right? And behind the Kafka side, on the other side, I can have a Java app with Kafka communicating directly to Kafka or to the Event Hub. So I don't need the Kafka in the middle here. I can talk directly Kafka to my Event Hub, which means I can go both ways. So I can have a C# app with no knowledge about Kafka talking to an Event Hub, talking to a Kafka consumer, right, without changing code, but just slotting in an Event Hub. That works for me, right? So this is the view of it. You'll see we've got some event producers, we've got collections, we have ingress, and then we have our stream processing. So this ingress is Event Hubs itself, right? And then we've got some stream processing, and I'll show you some of the stream processing. I'm going to show you, now I can't remember the name. For the life of me, I'll tell you when we get there, right? And then we've got some long-term storage, and this could be data lake, it could be a database itself, but we have many possibilities open to us now. And the best part of this is it's platform as a service. I don't have to worry about it. I don't have to worry about managing it. I don't have to worry about patching or anything like that. I can just use it. I can spin up more resources if I needed it, and everything works, and it works both ways, right? To Kafka as well as to the other world where we don't have Kafka, right? This is just the conceptual architecture. I'm sure you saw it last week if you attended last week. So we've got our producers, we've got the Event Hub with topics. It's split into partitions, and then we're going to send information over to it in different flavors and formats. So AMQP, and we have Kafka as well. So we're going to just move it into Event Hub. And this is the benefit, right? So the Event Hub doesn't just speak Kafka. We can talk in other protocols to the Event Hub itself, and it's fine with it, right? It'll handle it, and then we will get it to the consumers, right, through this Event Hub itself and our topics, which makes it a lot easier. So all of the benefits with a little less work. Now, if you know me, and hopefully neither Irina nor Sherry remembers this the next time, I'm supremely lazy. So I'm going to try and find the way that makes the most amount of sense, right? So I'm going to try and find this way that takes least amount of effort, least amount of admin overhead to do exactly what I need to do, right? And that's the important part. And this is why I love Azure, right? I should have actually worn my I Love Azure shirt today, but it's in the wash because I had to wear it yesterday. But the principle here is that simplicity of usage. the ability of bringing your technology that you have and then connecting it to the other technology. And this is exactly what we do with Azure, with Event Hubs itself, right? So this is the type analogy, right? You can play from anywhere on the type. You can fast forward or rewind and then play, right? So if you press record, you have two channels that you record on, and they both record at the same time. And then you can obviously play it back, right? So I can go back and I can see which messages there are. Data on my channels are different. Although I record at the same time, they will be different. And this is kind of the interesting thing, right? I can then listen to either my left and my right speaker, and this is my analogy, right? So I'm not fond of this analogy, but it makes a lot of sense. So left and the right speaker, they each play their own channel, right? And you can listen to either one of the two, but they play at the same time, right? So let's have a look at the benefits of Stream. And then we'll switch to a demo very shortly, because I'm keeping an eye on the time, because I want to give you guys some time to ask questions so you can win that swag box. But let's think about this, right? So remember when we were talking about batch, and we were talking about this massive amount of data. Now, one of the things when we look at the database is it's heavy, right? And we need tons of resources on this. And what if we could take away some of the processing that we need in this database and move it elsewhere, right? So what if we can offload it to the client, right? So you'll see here client-side cursors versus server-side. So the benefit that we get here is I'm going to get the client to do more work, but I have bunches of clients and I have bunches of processing, and then just hand it over to the server side, right? So where I need to do less. I get this replayability that I can relook at my messages, right? And then the ability to add new readers for all data. So this is the best part for me, right? Because a lot of the times you have to deal with legacy stuff, and you can't always change it, but that information is valid, and you want it, and the customer would want it, or you want it, right? But it makes it really difficult. I mean, I don't know how many of you are in the situation, or you've seen it, where people have servers underneath their tables, right? It's got the sign over it that says, never switch this off, right? And I always like asking this question where I go, okay, so why can't I switch it off? And people normally answer the same way. We don't know. We have no idea what's on this machine. But when it gets switched off, these things don't work anymore, right? And that's a bad place to be, let's be honest about it. But you occasionally need to deal with stuff like that, right? So getting that old data in and then just surfacing it in, because it might just be that the system is busy dying, right? So it'll be phased out, but you need to capture it. And why do we want to spend the money to go rewrite stuff, right? So we just want to use it, right? Scaling out is always important. So this scales out horizontally. So allow me to get more messages as we add TUs, so as we add more computational units, right? That's super important, because how do I handle it if suddenly I need to get more messages, right? So in the occasionally I call it the real world, but that's a bad terminology. But on the on-premise world, what would happen is you would have to plan for the worst case scenario ever. So if you were selling tickets, let's imagine you were selling tickets to a concert, right? Your normal pattern would be no activity, and then suddenly you would get, I want to say Justin Bieber, but only because my kids used to love him, and he sold tons of tickets. So suddenly Justin Bieber shows up, and now you just skyrocket with the amount of messages that we've got to send through to the system. And that's what we've got to cope with, and that's what we plan. We plan for this high mark, which is essentially a waste of money, right? Because most of the time we don't need it. And this is the scalability is important, right? So we get around that. And then we can provide strict order within a partition itself, right? So looking at the stream itself, that becomes important. Let's quickly have a look at platform as a service versus software. So no patching, no runtime monitoring, no load balancing, no software patching, no continual improvement. This is stuff you don't have to worry about. And let's be quite frank, why would you want to worry about it, right? Who likes patching? I can see in the crowd there's one person who likes batching, and that's awesome, right? You know, I mean, patch, enjoy your life, right? Be you. But I mean, this doesn't make sense business-wise, having all of these different things that you've got to do, like monitoring. It costs a bunch of money to do these things. So if you could go PaaS and remove all of this where someone else does this for you, right? This is perfect, right? It's fully managed. You don't have to worry about it. You don't have to worry about the configurations. You don't have to worry about Hadoop, cluster tuning, and so forth. And you know, I don't know if you've ever heard of this thing called this Kafka problem that they had in terms of being able to having to select either time or amount of messages, right, that you want to keep. So if you have a Kafka stream and you say, I want to keep 2 days worth of messages as a minimum, and I want to have 10 gigs. But now what happens is you typically choose one of these. So you say, I want to keep 2 days, right? But now what happens when you suddenly get bunches of more messages suddenly in a period, right? The amount of disk space that you needed is much higher, and that's not what you planned for. So it could go really kind of bad for you. If we switch that over and say, okay, cool, I'm going to work this out on space, same problem. Suddenly bunches of more messages. You have 10 gigs of space. So this is just a rough number, but you now only have 15 minutes worth of messages, and that's kind of a problem, right? And we get around this by going to PaaS, right? Because I can decide what I want. So you'll see here, this is the representation of software, right? Installing your own, you get your seeds, you get some land, and you have some implementations to farm the land, plant the seeds, and so forth, right? And this is pre-configured platforms, right? You get a farm, a little plot of land. It's got flowers on it, but you still need the implements, and you're still maintaining this yourself, right? True PaaS looks something like this. You don't do a thing, right? There's an entry fee in coming in, and that's what you pay, but you don't have to lift a finger, right? And that's the difference here. And that's what we're talking about. So let's look at streaming with Kafka. We're 40 minutes in, so I know that we're starting to slowly run out of time, but we're at a good spot. So let me show you the sending in Kafka, right? So if you have Kafka already, there's a couple of changes you need to make. So you need to add a Bootstrap server, and that Bootstrap server points to typically to your event hub, and then you have a value serializer that you need to add as well, and you add this to your producer, and the producer can then directly connect into event hubs, right? And this is essentially just comparing running Kafka on premise, but let's have a look at a couple of normal things, right? So what our aim is going to be is I've got this data warehouse here, and you'll see it. It's got a couple of tables, and this is not the right one. Let me show you the correct SQL Server Management Studio, and then I'll tell you what we're doing. So here it is, right? So I've got this table. It's called Call IoT Data. All I have is on my other machine, I have an application running. It's generating a Kafka stream, and then sending it right to an event hub. I've told it to send about 1 million a day, and it really pulls my resources, so I'm not doing it on this machine. And it just throws events, right? So what I've done is I have set up a streaming analytics job, and I've set up an event hub. So if we have a look at this event hub here, you'll see I've got one running, and you'll actually see the requests here. So if we look at an hour, I'm getting a bunch of requests in, right? It's not a super lot, but this is what my machine can generate in that hour, right? So you'll see on about average, it's about 2K, right? It'll spike up and so forth. And there, just before we started, I got an error, so I restarted it. But it's been sending in, right? So we can see the requests. Here's my messages, incoming, and then the outgoing, right? So I'm sending them along, and I can see all of this, right? So my throughput is listed here, and this is really kind of straightforward to switch on, right? And then let's quickly jump back and back again. And then I'll show you, let me just click home, that'll be quicker, at the streaming analytics job. So the streaming analytics job is set up to capture the events from the event hub. Now, what this gives me the ability to do is to actually direct these streams. So you'll see here, I've got a query, and unlike SQL or other databases, you'll actually see there's 2 queries in a row here. So number 1 is just give me a select star from my data, and I'm putting it into this one here, right? So I can see it. And then I've got another one here. And this one actually does some calculation. And you'll see I've got a tumbling window. And I'll explain what I've done as we go along, because they target different things. You'll actually see here, here's my inputs. I've got an event hub. And my output itself, you'll see I've got Synapse Analytics and then Power BI itself. And you'll see here my resource utilization and the monitoring over this itself. So this first part is going to go to Synapse, and the second part is going to go to Power BI itself. You'll see I've got Power BI open here. It's ready. It's primed. And there's no capturing in between these 2 things. So what I'm going to do in Power BI, first of all, is I'm going to switch on real-time data. And I just opened up Power BI. I created a new data set or workspace. Then I added a report. And I'm now here where I just said, essentially edit, add a tile. I clicked custom streaming data, and I say next. What you'll see here is that my data set is immediately here. So I can click on that, and I can simply say next. It'll ask me if it's a card. Yeah, that's a card. And it's going to ask me to select a column. And all I have is a single column, right? Because I'm sending through some real-time data onto a report. So this data isn't being captured anywhere. It's being streamed from my analytics right through into my Power BI with nothing in between them, right? So essentially as real-time as we can get. So let's just say real-time here. I don't need a subtitle. And we're just going to say apply. And yeah, it's happy with that. And then it should start flashing up in a second here. And hopefully, occasionally I do it too quickly for Power BI. So I get a warning from Power BI that the tumbling window is too small. And it gives me a little bit of flack for that. So if that happens, and we know what causes that, it's this window here for tumbling windows, right? Duration 1 second. And while we're waiting for this to see that it's okay, we're going to switch over to SSMS, SQL Server Management Studio. And let's have a look at this database, right? So it's a simple table. It's wide. It contains all of the information coming from that stream itself. So we're capturing all of this information here. And then we're just essentially just capturing them off of the analytics, right? So what you'll see here, it's maybe a little bit difficult to read my screen there, but that's the amount of records we had just before we started this call, right? So 279949. And I'm just going to issue a count again, so it gives me a new value. What we have right now is this amount here, so 309,000, right? So 309,000. So essentially about let's call it an hour, it managed to jump up by about 30,000, so like 20,000, not 30, sorry, 30,000, I missed the 9. And let's have a look, right? So we're going to refresh this again. And we'll see that I'm continuously adding rows in essentially real time, right? I've measured the amount of time that it takes from my little machine here in Copenhagen to get into the Azure data center and then be written down into Synapse itself. And the average is about 2 seconds, right, for my machine. And then the high point was 3.4 seconds. The lowest point was less than a second. I am sitting on fiber at home, so I've got a gigabit of fiber. It's a fairly fast connection, but there's a fair amount of distance between me and the Azure data center that we've got to take into account, right? And what this points out is that we can then move our data from our producers wherever they sit, bringing them into the cloud, into Azure, streaming them to Kafka, right, using our Kafka producers, streaming them into an event hub, and then just use it right from there. So if we switch back to the principle here, right? So, oh man, and the demo gods are just not with me today because this is not seeming to work. This is running, so it should be sending information. There it is. I can actually look at this Power BI, and it is going to, it's called Power BI Real Time. I might have messed it up. So you'll see here, there's the data set. There's the table name, so it's called fraud calls. And then it just sends it through to Power BI. So what you want to do in Power BI is probably delete my shame, add another tile, hit that, and then that should be this one, right? This is the one, I'm pretty sure. But let's have a look. So I'm going to say Azure Stream. And I was going to do here is then say, you can't do this, right? You can only select what we give you. So that's fine. We're going to add a tile. We're going to do this again. We're going to go next. And it should be this one, right? So it should be absolutely that telco real time. Visualization should be a card. We're going to add a value. It gets this information through. I'm going to click next again. And I'm going to kind of give up if it doesn't work now because we don't have a lot of time. I have probably about 2 minutes of talking time left. Right, so this then comes from Event Hub, sends it into streaming analytics. I can do a bunch of stuff here, so I can interpret the stream. I can also instruct Event Hubs to write this information down into storage for me. So I can write it down into blob storage, right? Just to give you an idea. So quick and easy. Getting it into the data warehouse off the bat, really easy, using standardized stuff. So I don't have to get my data warehouse guy to go and get special training. I didn't have to get my Azure guy to go do special training because we were just using Event Hubs, right? And we were just streaming it down into streaming analytics into my data warehouse. So there's nothing new that we're getting or having to do to get this data producer that's Kafka to stream into me, right? So we've got this old application, and it just works, right? It's capturing the information for me. So let's quickly just run through a couple of slides, and then I'll hand it over for questions. And yeah, here, right? So this is all of the stuff that you don't have to do. But the one that I wanted to talk about was the cost itself, right? So just the capturing, how we capture it down into data lake itself, how you set it up. But this is the one slide that I wanted to talk about, right? Because when you have a look at this, how do we sell Event Hubs? You'll see that there's two models, right? So here's where we look at. So you can see your events. How much do we charge you in these amounts? You would need to look at the pricing calculator. But you'll see that the first part is essentially a consumption-based pricing, and the second one is a resource-based pricing. So what you're saying with a resource-based pricing is, I have a manufacturing plant. It's going to be generating X amount of messages, and I need to handle this, and I'm always going to have this load. On the flip side, with the consumption-based pricing, you're saying, I've got a very variable load. I don't know how it looks through the day, and I'm happy to pay as these events come in. And this is essentially just how these two models differ from each other, right? And from me, thank you for listening to me. We're going to switch over to questions with Irina and Sherry. So Sherry and Irina, please take it away.
Thank you very much, Morne. Let me bring Irina on the screen as well for the nice introduction and session. So Irina, do you want to ask the question? We had one here. I guess Irina is not. She already started her summer vacation, so maybe I can bring up a question here. So we had one question. Okay. Yes. So
sorry.
No worries. So we have one question here. Is about that. I'm curious if commentary on batches also apply to structured streaming, macro batching, or if you see that totally differently.
So I mean, macro batching works really well, but the point I want to make is it depends on the data and how quickly I need to get it. So if you can micro batch, perfect. If your end result is matched, then you're perfect, right? Then we don't worry about real time. But I've been thinking a lot more about real time. I'm in a project right now where we've had to move 60 terabytes worth of data and merge it into a single database. So it was 7 databases when we started out. And one of the approaches that we're really looking at in detail is actually taking these databases, moving them in, and then to keep them in shape, right? So up to date, was to really just stream the data into them. And this is a valid way of doing it, I think. But microbatching is fine. So if microbatch fits with what you need to do, so your time to have the data available, microbatching is good, right? I'm not calling anything out as bad. I was calling out these really big batch jobs. You know, when someone says a batch takes 7 hours or 12 hours, and once again, sometimes there's no way around it. But I just don't like batch. I don't like batch for this reason, because if something goes wrong in that batch, you need to fix it again, right? And then rerun the batch or start from wherever it was, and then someone's in trouble or it's a bad day. So microbatching is fine. Batching, though, we need to rethink it.
Yeah, I hope it answered you. I cannot read your pronounce your ID properly. So if you have follow-up question, please type it there in the chat. Yes, said that. Thank you for clarification. And we have a request for you, Morne.
Sure.
And so the request was that one of the audience, Alex, he expected it more in depth talk about the Apache Kafka in general.
Okay.
So we wanted to ask. So does it mean that you are coming back here again at some point after summer?
Yeah, after summer, right? Summer in August, that would be fine.
No, for all of you that listening to us, we have 2 more after Dev Show, and then we are going to go on a summer break, and we'll come back in the late August. And then by that time, we are going to convince Morne to come back again for a session about Apache Kafka.
So you want it in detail, Kafka, right?
Yes, Kafka.
In depth. Yes.
Yeah,
all right.
Kafka. Yes. Okay. So I believe that these were the questions that we had in the chat. Let me actually share here my screen as well. While I'm sharing my screen, if any of you have more questions to Morne, please type it there and in the chat while we have him here. So thanks again, Morne, for all your actually for the nice presentation. And I guess you need to actually have one question to choose from as the winner of the swag.
That makes it really easy. I'll go with that question, right?
Yes. So I will put my actually I guess I have one here on the banner. So I will put my email address here. So email me, please. I am going to. You can email either to me or to Rasmus. We are going to make sure that you get your swag box. So for the rest of you, if you scan this QR code on the screen, you are going to get your Azure Heroes Learner Badger. And so if you never had a Learner Badger before, any of the Azure Heroes before, once you are scanning this QR code, you are going to download an app which is done by a partner engine, which is a digital wallet to keep all of these badges. And these badges, they are in reality, they are NFT token, non-fungible token. So that's why that we need to have them in the digital wallet. And if you want to know more about the program and then nominate yourself or one of your community friends for some of the other badges that we have, you can just go to this URL and read more about the program. And we have other badges, for example, like Kudos badge that Morne is going to get it today as being the speaker of the event. So there are multiple different of them. And please go ahead, nominate yourself or your community friend. And we have a Twitter account with all the updates of that. And if you check the hashtag, you can see that what community is thinking of this program. We have Irina back, I can see. Hi,
I
Irina.
managed. I think my laptop just melted down in Danish sun. But yeah, I guess I'm just right on time. And please provide the feedback. We're really looking forward to hear what you are interested, so that we can actually find speakers who can talk about things you desire. And there was a link to the feedback form in the chat as well. So make sure to fill that out. Let us know if there is something you would like to improve, or if you like the dev show, also please let us know. It will keep this amazing show going.
Yes, and also in addition to what Irina said, that if you have any feedback for Morne as well, we have a section for that, and definitely we are going to hand it over to Morne once you write it. And remember, there is a possibility to get another swag box there as well. So just saying. And as our upcoming event, currently we have a Cloud Skills Challenge going on as a part of DevShow. It is about Java and on Azure. And you have precisely 7 days left to finish it. If you want to participate in Cloud Skills Challenge, which is literally by going to some of the Learn module that we have specifically about Java, if you finish it out, it takes around, I guess, 3 hours in total, if I remember right. You can also get some specific other swags as well. And we are going to announce the top 3 winners on our next show, which is going to be with Rory. A second part of getting us started with Java and Azure. And in this session is going to be more of a focus on hands-on and then more demos compared to the previous one. Previous one was more a high-level introduction, and this one is going to be more of a hands-on and demos. So tomorrow, my peers in UK, they are running the Tech Days. This is going to be speakers from both Microsoft and GitHub, and then you will have chance to bring all of the questions to actually to ask them as well. So if you want to register, the URL is here. So I really recommend it. It's really fun events that they have on different topics, and this one is DevOps. Otherwise, the day after tomorrow, you can join the .NET user group. Has one of the speakers that actually I love her very much and I adore her very much, Julie Lerman. It's about the tackling the system of complexity with a domain-driven design. It's going to be more of a kind of a deep architectural talk. If you are already subscribing to our 4Devs channel, it's going to be streamed there on YouTube on our 4Devs channel. Otherwise, you can actually, if you're a .NET developer, you can actually go to this Copenhagen.NET user group as well. I really recommend her. She's amazing speaker. And it's not 15th, is it? So yeah, we want to see you today again, but I believe I should say that 15th plus 7. So see you next week at the same time. And again, thank you, Morne, for the great session. And thank you, Irina, for being an amazing co-host with me today. And yes, so see you all next week. Bye-bye.
Cheers.